is going to be, this is Saturday morning right now. And first, let me say that a new rule is that, or a new procedure for me is that Friday at noon, or 12:30 when I leave, or 12:45, when I leave Norman High, I am off the clock until 12:30 Saturday afternoon. So normally I try and get if you're virtual and you were looking for, you've been gone, and you were looking for the screenshots and the wrap-up video from yesterday, you won't find, most likely, you won't find Fridays until Saturday at about 1 p.m. would be when I want to get Saturdays up. Okay. So I'm off the clock for 24 hours, Friday, 12:30 till Saturday, 12:30 p.m. I shouldn't be answering emails. I'm trying to devote 24 hours a week to my wife and my house because it's falling apart. And so I need to just think about, for 24 hours a week at least, I need to think about something besides you guys. So it won't be available. Letting you know that. Anyway, so I'm going to, in this Zoom, I'm going to try and pick up what happened on Thursday. Now I added a video. I think it's on, yeah, it's on the Canvas. And all these videos, first place they get added is the YouTube channel. So you should always go to the YouTube channel or subscribe to the YouTube channel, and that's where you'll get the information before anybody else. And it takes me a while sometimes to link that up to the Canvas and link it up to the Facebook. It goes this way. It goes YouTube channel number one, first place, then Facebook, usually, then finally Canvas. So if all you're doing is looking at Canvas, you're getting something that's already been around for a little while. It's finally got to you. So it doesn't cost any money to subscribe to YouTube, to my YouTube channel. So anyway, so I'm going to try and show you. I have a video on there which shows me in the hallway doing the 5 phases, and so that's already on there. So now I'm going to explain a little bit more about, and I put screenshots. The bad thing about screenshots are, when you look at the screenshots, you've already got the answers. So I'm going to have to rethink how I do these, especially for virtual kids I'm talking about. I mean, the screenshots are fine for wrap up for those that were there and need something to look at. But when you're a virtual student and your first thing you see is the answer and it's all worked out, and then you go, oh yeah, and then here's a video of me showing how to work it out. It just, the brain doesn't work that way really, you know. I realize that, but I'm trying to get screenshots up. My latest idea is to have screenshots up like before I leave school, like by 1 o'clock, 1 p.m. each day, at least have the screenshots on there. And then a lot of times something's going on and I can't get to because it takes a while to make these Zooms. So I gave myself till 6 o'clock p.m. normally, Monday through Thursday, to get the Zoom video up. But by then you've already seen the screenshots. See what I'm saying? So I don't know how to do that because you do need to have the screenshots, right? I mean, I could make the video first, then put the screenshots, but what's the difference? You can still, when you click on that page, you have the screenshots eventually. So I don't know what to do about that. You guys, you're smart. You can suggest something simple, nothing complicated, but something simple that might fix that problem. Yeah, I mean, what I could do is not put screenshots up and just put the wrap-up video, and then you're kind of forced to watch the video to get the screenshots. But my thinking is, sometimes you don't have time to sit. You virtual kids especially need to let me know about this. You don't have time to sit and watch me drone on and on like I'm doing right now. You want to know what happened. And then maybe if you see the screenshot, go, whoa, I don't get that. I better watch the Zoom. Or you see the screenshot and you go, okay, that all kind of makes sense. I don't need to watch the Zoom. See what I'm saying? So that's kind of where I'm at now. And you guys can let me know if you'd rather do something else. Okay, so I'm going to be talking about both Thursday and Friday to kind of make sense of it all. So I'll go ahead and share the screen. Let me pause it for a second while I get that set up. So this says for Friday, but it's also, I'll also throw in a little bit of Thursday as well. Okay. Well, Friday we did our first Flashback Friday, and I don't know how to do this for virtual kids, so too bad. We ought to do it. It's fun, but we only do it the sweet, sweet bells go off at about 7 minutes before the end of class. And so not every Friday, but a lot of Fridays we'll do Flashback Friday, where I play either lines from movies or lines from songs, and the kids have to shout it out. What is the movie? What is the song? And then they get starbursts, and eventually we have a flash off in May. So it'd be kind of cool if we could have a virtual division. Yeah, I don't know. Something we need to think about. You know, probably, I'm thinking virtually, probably because we need to have some kind of cohesion. I mean, right now you're all kind of lone rangers out there. And so maybe what we need is, boy, I hate to do this, but maybe we need a Zoom a week, you know, an hour long. Now we're having one Monday night. And so far we've kind of had a Zoom each week, a live Zoom, but we probably need to pick a night, maybe Monday on typical, maybe Monday should be kind of the virtual Zoom night from 9 to 10. Now, Zoom kids, we're going to do one Monday. So that doesn't make sense because that's kind of the first night of the week and set the week up sort of thing. So virtual kids, you guys need to, on the virtual, Unit 5, I believe, on the Facebook group is set aside for virtual, just logistics, not physics stuff, because I got really smart virtual kids, so I don't want them to ask all their smart questions just in that area. I want everybody to benefit from that. But I think we need a unit. I was looking at that room, but it doesn't work. That's for like, that's Facebook's answer to Zoom, but which may be cool. I don't know. Anyway, so Unit 5 is where the virtual kids can just talk amongst ourselves, yourselves and me. And you can also comment there. I'll put questions on there, I guess. And one of the questions is, probably the first question is, are you cool with Mondays from 9 to 10? I don't like to go 6 to 7 or 7 to 8. I don't want to just go right in the middle of your evening. People have sports, they have events, they do stuff. But usually by 9 o'clock, people are settling down. And so I'll record all those. Those will be our weekly Zoom kind of check-ins for virtual kids. All right. Anyway, back to this. I'm sorry I'm taking so long here this morning. Sleepy, I guess. So there's Flashback Friday, and maybe on the last 5 minutes of our weekly Zooms, we could do some just for fun. It'll be Flashback Monday. And this is a yellow sheet. It's not yellow here, but when we printed it off and copied it off, it's yellow. And this is for virtual kids. I have some. If you don't have to make it yellow. You can just print off a black and white one. It's fine. But for my virtual kids, I put some yellow ones in the box on the front porch. And most of you by now know where I live, 812 Carriage Lane. So, and I'm looking for. I had some lit up pumpkins that I was going to set around there so you can see. I see some of you come up at night. It's like, it's like 9:30 at night and it's dark and you're fumbling around on the front porch trying to scare the bejeebers out of my wife. So I should always have the porch light on, but I'll light up these pumpkins so you can see it. Okay, if I can get them out of storage, there's a whole situation there. Anyway, I'm just going to tell you what I told the kids in class. Make sure you put this is a cover sheet, goes in the front. I don't need to see your name on every sheet of the packet, but I do need to see your name at the front of the packet organizer, all right? So it's an easy 3 points. You virtual kids, you would circle virtual. And I keep saying as if only virtual kids are watching this. I know that I have like Finn and some other people that are out, for various reasons. So you guys are watching this too. Packet one's worth 116 points. The notes are 34, and you're supposed to check off these boxes. So we have 2 columns of boxes. The first column, this column right here, this is what you check. Now, the reason why that column's still there, I used to hand out papers one at a time. And then the kids had to kind of put them all together towards the end of the packet. Well, I'm handing them out a packet at a time now, which I kind of like. But so that's already kind of done for you, the organization of 1-1 through 1-8. So unless you've ripped some pages off, you should have all that already. So the first column is just checking kind of for the kids asked to have these boxes many years ago. Then there's a checkbox to make sure you've included your take-home tests. Now, those get included on the back. So we kind of call those virtual 1.9, 1.10, and then those are with 4 points each. So even if you didn't do it, you still wouldn't turn in the paper, you get 4 points. If you don't turn it in, you lose those 4 points. So just turn in your take-home tests. Will you get them back? You'll get your packet back. And right now I'm leaning towards, yes, I'll just give the whole packet back to you once I look it over. So you're going to have your take home. I used to kind of keep those from circulating too much, but now I don't really care so much. It's fine. The in-class tests aren't circulated, so I'm okay. Hey, if you want to give your little brother your take-home tests, if it helps him or her, little sister or something, that's fine with me. For next year. All right, so or 2 years from now. So you'll just get this whole packet back once I grade it. And then your packet notes goes on the back. Now, I was thinking that a lot of you were taking your packet notes on loose paper, but then when I did a survey of my classes, they said, whoa, no, no, no. A lot of us are doing it in a notebook, and we don't really want to rip the pages out of the notebook and stick them on the back of your packet. So I said, okay, in that case, if you want to keep your notebook together and not rip out the pages, then just turn the whole thing, stick 1.1, the cover sheet, and 1.1 through 1.10 stapled together in your notebook, right where your notes begin. Okay. Now here's the only problem with that. If you have a notebook that's just dedicated to physics, it's not that big a deal. I'll get that notebook back to you. You'll turn it on Tuesday. I'll probably have it back to you by Thursday or Friday at the latest. But if you have your math in there and chemistry or some other subjects, then you're not going to have your notebook for those subjects if you turn in your notebook. See what I'm saying? So you got to make a decision here. Either rip out the pages or, I can't have photocopies because I've had students over the years photocopy other people's notes and call them their own. So I won't take photocopied notes. So you can't do that. So I guess I'll try and get this back to you as soon as I can. But from now on, if you're gonna keep all your notes in a notebook, which is a good idea, you should have a notebook just dedicated to physics. It can be one of those cheap Walmart $1 note composition books if you want. You could have a new notebook for each packet if you take a lot of notes, I suppose. Anyway, okay. So all that gets turned in Tuesday with the test if you're in class. Now, if you're virtual, I guess I've got to finally make a final decision on that. I've offered a couple of things. I'm going to be in my room on Tuesday afternoon till, let's say, because I got plenty to do. I got plenty to grade and all. So I'll be there Tuesday. I'll go to lunch, and then I'll be back in my room Tuesday by, let's say, yeah. So I'll be in my room from 2 o'clock in the afternoon on Tuesday to 4, 2 to 4, or 2 to 4:05. Okay. So if you can brave it. Now in that room, there will only be me. There's no other classes in there in the afternoon. So if you want to brave it and come up, and I have a fan on, the windows open, the doors open. There's pretty good breeze in there. And if you're cool with that, one option is to come up and take the test in my room, paper and pencil test. And I'll give you an hour like I give everybody else to take it. Okay, so that's one option. Option number two would be to come up to school and then go out to the West Lawn. And this will be Tuesday afternoon. Go out to the West Lawn and sit on a park bench, sit on one of the picnic tables, and I'll come out and check up on you, that way. If it's not raining or something, if it's not too windy or crazy weather. And it's kind of distractions out there is the only thing, but I'll give you, the right amount of time. And I guess another option is to do it through Zoom. That's just still weird to me, but where you Zoom in on Tuesday evening, this is the third option now, I guess. You Zoom in on Tuesday evening, and then at a certain time, say 7 o'clock, you take the test, and I give you pure testing time. I'm not talking about intro and then trying to send it in. Pure testing time, you would get an hour, or 58 minutes, whatever everybody else gets. And I would just set the cameras on you, and I'm there, and to answer questions. We're all Zooming together, and you have to have your camera on, man. If you're going to Zoom in like that, the whole point was that I'm still there with you, so I have to see you. So you may not want that to happen. So I'm giving you three options: one in my room, two at the picnic tables. These are all Tuesday afternoon, or three Tuesday evening and I'll write all this down, I guess, and then get it to you guys. I'll put it in the Unit 5 of the Facebook group. Okay. And on that Unit 5 of the Facebook group, I'll tag everybody that's virtual so that they're aware of this Unit 5, because that'll be a good place we can communicate. Just virtual kids. Okay, so that's a lot of housekeeping today. Homework, there's additional homework. Homework was 2 and 3 on the Facebook group. And here, so remember that the best place to go for virtual kids is Facebook. So this is 2.1. Mostly it's going to be homework. We did 1 in class at the boards, but 2 and 3 was homework for everybody. But then you see here, and Eric is a virtual student asking questions. Avery's not a virtual student, but any student can ask questions here, and we appreciate that. Eric said QFA, which is really good. I get a notification, but that's only if I'm on Facebook. So I don't like it. My phone doesn't buzz, but I do get a note once I get on Facebook. So I'm on Facebook probably because I'm looking for you guys, basically, 2 or 3 times a day, maybe 4 or 5 times a day, depending on what's coming up. So Avery then got on there and asked another, or made a comment, and she should have probably put QFA, but that's okay. I caught it. And so then I'm answering here. We're having a little discussion, and I'm not necessarily going to answer your question, just unless it's just a very simple question. I'm going to give you hints. And so I would like Eric to chime back in here and say what he would do. But remember, I don't want people just going to Facebook and just getting all the keys. We eventually post a key, but while we're working on it, I want it to be a back and forth, because it's really hard with virtual kids to get anything back and forth. The only time we can do it is, I think, on the live Zoom on Monday evenings now, I guess, and on Facebook. All right. But Facebook is 24/7, except for Friday at noon to Saturday at noon for me. Okay, so back to this. So the homework then is 4 and 5. Now, we didn't talk about that at all in class. I just assigned it. And so once again, I say 5 minutes, 5 minutes per problem. All right, 10 minutes total. This is just, I want you to give it a good shot. The key will be posted, and we'll probably go over these two. There's nothing really new about these problems, about these graphs, but it's just, this will actually help you for the test. So will really, the whole sheet will help you for the test. Although it's not on the test, it's 2.1. It's sort of a review of some things that happened in packet 1. So it's a good thing to do anyway. So get on 4 and 5 this weekend. You're not wasting your time. It's helping you with the test for Tuesday. All right. So, and then ask questions on Facebook about it, like we did here. All right. So I apologize for throwing this completed worksheet at you, but I am going to go over kind of how we got this. And in fact, I was whiting everything out, and I was going to unwhite it, and I just screwed up here because I didn't. But that's okay. So let me go over this. We showed you there's a video of the hallway, and we showed you what was happening. So I went out on the east-west hallway in the science building, and this first phase at Delta X1, I stood there, and if you watch the video, you'll kind of get more of a visual of what I was doing. And I did the old man walk for the first 3 meters, and then the students timed me, and it was about 9 seconds for most classes. And then 3 meters to 10 meters, I did the aerobics, and that was a little faster. Got to show off some of my aerobic skills. I think I tweaked my shoulder. And then from 10 to 15, I did the old marching band, how we used to march in Ponca City. And then we timed that. And then the next day we came Friday or Thursday, we came in and we did, I ran from 15 to 3 meters. And I started running before so there's no acceleration. Like I didn't start from 0 at 15. I started before that and ran and got to a certain speed and then ran. And then I said start at the 15-meter mark, and they timed me, and I ran through the finish line. I said stop as I ran across the. So they marked me there, and it looks like it was about 3 seconds on average for most classes, 3 seconds. And then I did the funky chicken from 3 meters to -4 meters. And I was going to show you that with the selfie stick, but there was a bunch of dudes putting in all these ceiling wires, and there was a mess, and I couldn't put my music on. And so I just had to kind of walk you through it, unfortunately, for those that weren't there. All right, so then we wrote down the times in this table. Those are called interval times. And then there's this new thing called tau. Tau times are total times. So it's like accumulated time. That's what tau means a lot of things in physics. But one of the things it means is like when you're adding up all your times, you call that the tau. So 9 seconds for the first one. The second one, then 9 plus 5 is 14 seconds. And then the third one, 9 plus 5 plus 7 is 21 seconds. So you can see where the tau just gets added up. Now this helps you a lot when you're plotting it on a graph, because you want to know what's my time quote, what's my time position, or what's my time point here where I'm plotting these. Okay, now I already have the interval velocity in there, but we didn't do those yet. The next thing we did was we plotted our data. So you're seeing all these. I wish I had a backup. I do have a backup button, but on explain everything, once you go past a point, that all those backups get kind of tossed. So you can't just back up. Anyway, so we have all 5 phases listed here. The blue and yellow mean that I was going forwards. All right, so that's the old man walk, that's the aerobics, and that's the marching band. And you go, well, how are you getting these numbers? This 0.33, this 1.4, those are simply the slopes of the line. And if I'm plotting position versus time, then the slope would be velocity, okay? So those are my 3 velocities, and then those go up in this table here. See, 0.33, 1.4, 0.71 meters per second. Then here's what I do. And just to emphasize it, because when I went backwards, I didn't turn around and run backwards, but I'm saying I went from the 15-meter mark to the 3-meter mark. So by my scale, with the reference point here at the origin, that is considered backwards. So I ran that 4 meters a second, but notice it's an upside down. So I changed the color too. And in your notes, if you have access to color pencils, you should get access to color pencils, because on tests, you have to use color pencils. So you've got to get used to using colors. So the yellow color here means the 3 moving forward. The 2 reds mean that's the run and the funky chicken. So those are the 2 running backwards, running back to the origin, in fact, past the origin here. And the green here is the overall average. We'll get to that in a minute. So you see how it's so nice to have colors. I can just talk about yellow, red, or green, and you can see what I'm talking about. So it's a bit of an inconvenience for you, but I think coloring should be something you're pretty good at. You've been doing that since kindergarten or preschool. Okay, so this is negative, and we all like to color. I mean, it's soothing to the soul, yeah? Just stay in the lines. So this is -4, negative, and then this is going to be negative 0.58. That's funky chicken. So then we will do this in the back, but since I got it right here, we also want to know the overall average. Well, let's hold off on that. We'll come back to that. The green. We'll come back to the green in a minute. The green went on the next day. Okay, the blue and yellow went on one day. The red went on the other, and I think that then the red and the green went on the next day. So we talked about what is the difference between distance and displacement, and scalars and vectors again. And so the overall distance I traveled was 34 meters. Now you got to see why that is the case, right? Because I went out to the 15-meter mark. I came back to the 0 mark. Then I went through that to the -4 mark. So when you add that up, 15 plus 15 plus 4 is 34 meters total running. That's my whole path. But displacement only cares about where I started and where I ended. So displacement only cares about this point on the graph and this point on the graph. So when you put those together, you find out that you really only went 4 meters. Because remember, displacement is a vector, and vectors have to be straight arrows. They have to be arrows, one-directional arrows, not multi-directional, not omnidirectional. Those are scalars. So scalars either have no direction or they have multiple directions. And so you have to be able to represent this thing with a arrow. Okay, so vectors are limited too. Because vectors are great. They tell you what direction you're going, but they don't tell you if something's radiating. So you can't use energy. Well, you hear that? We know what time it is now, Saturday at noon. So you can't use vectors to represent energy, which is a huge concept in physics, because all energy radiates, right? So like the sun shines in all directions. So energy and like a heat from a fire goes in all directions. It doesn't rise. It rises, but it also goes forward and backwards and down. So we can't represent those with vectors. Those are scalars. All right, so now we talked about the analogy here with the baseball and looking at 90 feet between, looking at 90 feet between bags. I'm pointing to the screen as if you guys could see me. Okay, so 90 feet between home plate, first base, second base. So we said, well, what's your distance for a single? That's 90 feet. What's your displacement? That's 90 feet. But then we go to a double. Well, for distance, I run 180 feet, but displacement you remember, you cannot have a crooked vector. You can't, if you're going to shoot a bow and arrow, you can't have a crooked arrow. So all arrows are straight. And so I have to represent this from first to second base as a straight shot, not going to first. So the vectors only care about they're called, like in chemistry, you call them state functions. But in physics, there's differences, but the idea that they're the same in that a state function in chemistry is an energy function, and where you end up the path you get there doesn't matter. It's where you start in energy, where you end in energy. But that's really AP chemistry, I guess. But in physics, its displacement is a vector. And so I can show it as an arrow for this green. It'd be a green arrow from first base, from home plate to second base. And that's 127 feet. That's just Pythagorean theorem. So a catcher always impresses me because he or she, if it's I guess you can steal. I mean, girls softball. I'm sorry, I'm so ignorant. I watched the World Series. Anywho, um, I don't know. Anyway, in baseball, so say you're stealing second, a catcher's got to get from a crouch position with all the equipment on and throw off their mask and then throw the ball, pinpoint the ball right to the second baseman's glove for the tag. That's an amazing throw. One of the hardest things to do in baseball is to get that right. Anywho, um, so for a triple, that's 270 feet. But for the displacement, in that case, for a triple, I'll add a little arrow here. That's just here to there, right? That's for a triple. And so when I coached little kindergartners, they would, off the tee ball, they would hit the ball off the tee and then just about half of them would run to third base because they didn't realize, oh yeah, you got to go to first base. So very efficient. So in that case, you don't go through the path, you just go right from home plate to third base. So it's only 90 feet for a triple. And then for a home run, 360 feet, but it's zero. There is no vector in a home run because you began and you started at the very, it's where you end where you started. So, okay. Oh, sorry, this is kind of housekeeping here. This is out of place, but I'll throw it in there. Students were asking where do I put these? Like I'm giving you guys, like for virtual kids, you'll get points. If you get a FBP, that means Facebook point. And so I'll say, oh man, what you said was so cool. Here's 2 FBPs. And so you need to, I used to do this by stamps, right? I would stamp the front of the notebook, but we're not doing that anymore. So you need to keep track of these. So at the top of your Pkt2 notes, at the very first page, you should title it, take up some pretty big letters and say Pkt2 notes. And then below that, somewhere in a box off to the side, somewhere where I'll definitely see it. Don't hide it. Maybe put a red pen around it or something. Put these 3 blanks, either discussion points, Zoom points, or Facebook points. Now, virtual kids really can't get the discussion points, but they can still get Zoom points and Facebook points. And these are all bonus. I wrote a little note to you here, but these are all bonus points. So I made the red slashes up. I'm just making a point that you don't write down a number, like you don't put 3, you put 3 little slashes. And so we'll just kind of keep track of it this way. So if you have your notes out every day and I say, oh man, that was a good point. So give yourself a discussion point for that. You'll keep marking. And then I will add these points to your Pkt2 notes rather than wait. My original idea was, well, it's a mess and we'll just tack it on at the end of the semester if you need it, right? But that didn't sound very good. So in other words, if you had an 89.1 and you're trying to get the A, then you would cash in your points. But that's going to be a mess because I'm sitting here at home, grading your stuff, and it's, December 30th, and now you're supposed to somehow communicate with me that you have. That's a mess. So we're nixing that idea, and we're going with this for points, so that you'll get them as you go. So yeah, discussion notes for Pkt2's worth 34 points. Now Pkt2 discussion notes might be worth more. I mean, that'll vary. And so you may end up, if you get these some from Zoom points or Facebook points or discussion points, you may end up getting, say you had this situation that's on the screen. Well, you got 7, 8, 9, you got 12 discussion points or extra points. So you would get, if you got a 34 out of 34 in your notes, you would get a 46 out of 34. So you just get that bonus. Now, if you don't get any, well, it doesn't hurt. I mean, you ought to be getting some just to kind of make sure you're still alive. If you're not really, that means you're not really participating at all in anything. And you need to participate to understand physics, unfortunately. So as far as notes go, Miranda has her notes, and if Miranda's listening, I would love for her to give me a 4th I have 3 pages, but I'd love a 4th page. I know it's harder to do notes, student notes, if you are sitting at, now Miranda's virtual, if you didn't know. So it's be harder for her to take notes. She'd have to kind of recreate screenshots or in her own way, or listen to Zooms or from these wrap-up videos, take some notes if she wants to. It's totally optional. But it's kind of nice because I know I've had some students looking at her notes, desperately trying to get some kind of notes on paper. So the question is, well, I only got 2 paragraphs of some chicken scratches here, half a page of garbage. Should I? Yeah, go ahead and hand that in. You'll get something for it. But I don't really know. I'm not sitting there watching you guys take notes, so I don't know what a typical student notes are. It's not a bell-shaped curve, my grading. I mean, I hope everybody gets 34 out of 34, but I know some kids have taken no notes. And so this is some incentive. I mean, I guess you can just lose 34 points, but there's some incentive to writing down your thoughts. Now, your notes could be just you practicing. A lot of students get a lot of points this way. Just you, like on scrap, not scrap paper, but in your notes, practicing problems. Like we used to do a lot of practice problems. So you could, not your homework, but just like additional problems, additional work, things you look up on Wikipedia, whatever could be in there. If you're virtual, you're going to have to probably also not just listen to me, but maybe you watched another YouTube. You're going to find there's a lot of good, and I've put some in the references for the in the Canvas. I put some like Doc Physics is really good. Bozeman Physics, of course, Bozeman Science is excellent. There's a lot of good YouTubes out there. And if you find one that I don't know about, let me know. But maybe you're taking notes from that. So any kind of place where you write down some stuff or some thoughts on physics, that's where you would keep your notes. Okay. So there's that. Let me know in the Unit 5 of Facebook if you have questions about that. And by the way, virtual kids, you would turn in your packet and your notes when you come in to take the test. If you are doing it virtually on Zoom, you're going to have, I still need that packet. So I'll put another box on the front porch, kind of an in-box, out-box. You could mail them to me, I suppose, if you want to put them in an envelope and drop them in the mail. But there is still kind of a deadline on that. So I don't know about the mailing idea. But I need to have them on my porch by midnight Tuesday. Okay. Next week, your packet and your notes. So maybe you drop them by the school, whatever, but I do need that. I do need that physical packet done, not submitted through Canvas, done, and me have it in my hands. We're only going to do that 2 or 3 times a semester, but I've got to see your handwriting. I've got to really be able to write stuff on there, think about it. That's kind of how I grade. This virtual stuff is weird. Anyway, so now we're going to spend the rest of the time looking at the back of this. So we went to the board to do this, and what we're doing on this graph here, and I'll actually start doing some of this with you. What we're doing here is we're trying to figure out the velocities. It's called a velocity graph. So avert your eyes and don't look at the screenshot because I already have the answer there, but it's better for you to kind of think about it as we go. But this is you would call this, you have to give a title to all your graphs. So you'd call this a velocity graph. You can also call it a slope graph because that's what it is. You're plotting slopes. And it's also, if you want to get fancy, you can call it a derivative graph. And it's all versus time. So remember, a graph is always one axis versus the other. So here we have V in meters per second versus time. I already know what's going to happen. I'll put time up here. Time in seconds. Now, the reason why I didn't put time down here is because I know that I have a lot of negative velocities. So we look back on the table, and all we're doing here is we're plotting. Oh, shoot. Okay. We're plotting. I'm going to have to go, hold on a second, do a little work here. Let me move this guy so it's right next to that guy. Okay. So, yeah. So we're plotting these points here. We're plotting these velocities, these slopes, right, versus time. So here we have the actual position versus time on the front of the sheet, and then the back of the sheet, it's a corresponding graph. In fact, it's called a duet. So duets go together, right? So the v x versus t and then v versus t is always below it, and that's the duet. We'll get into this more next week, starting Monday. All right, Tuesday, of course, the test, but the rest of it, we'll be doing a lot of these duets back and forth. We can go from the x versus t to the v versus t, or you can go from the v versus t to the x versus t. Now, the x versus t to the v versus t, what we're doing right now, if you extend this onto calculus, that's called derivatives. You're doing the derivative. Kind of a cheap man's derivative is just doing slope. Slopes are okay for linear functions, but as we're going to see probably into next week, that with accelerating functions, that's not so easy, but we'll get to that. I'm getting way ahead of myself. So what we're doing on this graph is we're just plotting the slopes versus time. So my time is going to correspond. So here we're here on time. Now the reason though I'm not doing it all, I'm not putting the origin down here, is because if you look back here at the velocities, we have negative velocities, those in red there, and then we have the positive velocities. So it looks like our range of velocities goes from 1.4 meters per second to -4 meters a second. So back on my graph, this is where all the students were doing at the board, and I was kind of giving them hints, and they did a really good job. I took a picture of third hour's board work. Yeah, that was really good, I thought. So this is they gave me hope. 2, 1, 0. I don't need to put any units on here because I already have units on that blue. And then -1, -2, -3, -4, -5. And for time is still the same. It has to line, these graphs have to line up with each other because eventually one's going to be above the other, as we'll see on the next worksheet. So times then, blow this up, we got 10 seconds, and I already put the seconds up there, 20 seconds, 30 seconds, 40 seconds. All right, that's plenty. 40 seconds. Yeah. Now, 40 seconds. Man, I'm running out of coffee. This is going to end in disaster. Okay, maybe a couple sips left. I can get through this. All right, so here we go. So now we're ready to plot. Well, this is the problem the students had, and I kind of let them figure it out themselves, and they did a good job at the board. And I said, listen, I'm not going to say anything, and you guys figure. I'll give them some hints, but you guys figure this out, and they did. Okay, let me plot. You always want, when you have something in the first and fourth quadrant, you always want to emphasize that. So I'm going to give me a big, thick black line right there. Because anything in the first quadrant, if it's velocity, anything in the first quadrant is going forwards, anything in the back quadrants going backwards. So, and I wrote this, if you look at the screenshot, well, don't look at the screenshot, but I put this in yellow, that anything in the first quadrant is forward, anything in the fourth quadrant is backwards. Now, we notice we don't, one group started plotting things in the third quadrant, and they realized, I didn't tell them, but they realized their mistake and said, wait, no, that can't be, because you can't have negative time. So it's kind of cool because they realized they did something wrong without me just, spoon feeding them. So that's what I want. I want you guys to go through and make your mistakes in a safe environment in a friendly, non-judging environment. And then when it comes time for the test, you've already made all your mistakes, so now you know how to do it. But if you don't ask questions, or if you're virtual and you don't really, it's hard to be virtual. I think you can tell me that, but the problem is if you're not aggressive a little bit, and a lot of you virtual kids are, which is good. If you're not going to, you have to take your education now by the horns, and you're making a choice. You're wanting to protect yourself and your family, and that's good. But with that though comes a responsibility that you've got to get on that Facebook. That's the main thing, or get on the Zooms. Never miss a Zoom. Watch these wrap-up videos. I'm sorry I'm going so long today, but normally they're no more than 30 minutes. But watch these, okay? Maybe fast forward through parts of them or something, but you do need to, it's the only way you're going to learn. I mean, I can tell you to memorize some stuff, and that's not going to be, that's a joke. So you really are trying to learn physics. Okay, I just see it's not going to be easy. We're on the easy part right now, by the way. All right, so it gets harder. So we start off at 0.33, and we do that for 9 seconds. So I go over here, 0.33 puts me about, it's a third. So that's 0.4, right there. And I'll go, I guess, red here, since we were doing red earlier. And it goes 0 to 9. Okay. So it's flat, and that's what bothered students. So what do you mean flat? Well, if you think about it, within the interval, there was no, this is the old man walk. I didn't start speeding up when I walked. I walked at a constant rate the whole time. So the interval velocity here is 0.33. It's flat. It stayed constant for that interval. This is called a piecewise function. Now the next phase was the aerobics, and that I was going at 1.4 meters a second, and I did that for 5 seconds. So I come back here, I pick it up there, I'm stitching these together. So 1.4 for 5 seconds puts me at 14 seconds total. Okay, so I just made a mistake. Now think about this. What mistake did I make? This being a function has to pass that. Here's my vertical ruler. So this being a function, it has to pass the function test. So all the tests of the function. Well, one of the function tests is if I take a vertical ruler or a vertical line and I run that along that graph, that function, I can only have one velocity for each time. And that just makes sense physically. I can't be going at 2 velocities at once. So now you got to go back to when you were in 5th grade and you learned the old open circle, closed circle thing. So we always put open circles. If it's a piecewise function, you put an open circle at the end, not at the beginning. It wouldn't make any sense. At the end of each one of these. So you don't have any, so you can pass that vertical line test. Okay, so you're not trying to do 2 velocities at once. Okay. I think the kids in class did real well. They picked that up really fast. 0.71 meters a second is the next one. This was the band. And so 0.7, I did that for, looking up here, for 7 seconds. That's where I'm getting all this. For 7 seconds, it puts me at the 21 second mark total. So 0.71 to the 21 second mark. All right, where am I? There it is. All right, so to the 21 second and 0.71, I can't, my memory is horrible. To the, really? Yeah, to the 21 second mark. 0.71 puts me about right there. And I go to the 21 second mark. Open circle. All right, now I go to the run. So we go back here, and the run is -4 meters a second. Remember, Usain Bolt runs at -10 meters a second, or at 10 meters a second. So I'm running about 40% the speed of Usain Bolt. And now I do that for 3 seconds. So I come back here, and for 3 seconds, I'm way down here now, that big, huge jump. For 3 seconds, I'm going to go blue, I guess. How was I doing it? Oh, I got them backwards. Oh, well. I'll change colors here. Then I'm going to go, well, that's confusing, but I'm going to go blue now. So at 21, starting at 21 to 24, 21 to 24, little tiny line. That's it. That and open circle here. Oh, geez, sorry. Oops. Okay, there. Foul up. So open circle at the end of that. Okay, that looks closed, but it's supposed to be open. Let's try it again. Open circle at the end. Boom, boom. So to 24 seconds. Okay. And then we go negative 0.58 for the rest of the time, and that's the funky chicken. That goes all the way to 36 seconds. So negative 0.58, way back up here. So from 24 to 36. 24 to 36. Really? Okay. Already there. Now this last segment doesn't need an open circle because it's not competing with anything. And that's what the graph looks like. That's the overall, that's the 5 phases. So both these graphs mean the same thing. This graph and this graph mean the same thing. It's just different interpretations of the same thing that happened. But what we just did was we took the slope graph. Also, these are like taking the derivatives. And derivative, we're going to get into it more later, but derivative means change. And so it's we're looking at, and in derivative is instantaneous change. So there really wasn't any, notice there wasn't any change within each interval. There was overall change, but not within each interval. So these are all flat slopes, meaning that there's no acceleration. The slope of velocity versus time is acceleration. And so there's no, since these are flat, there's no accelerations. Some students did this little innovation. They dot, 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 and that's okay. Just don't do them straight lines. Like they wanted to show that there's a connection. So dot, 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 and then keep that dot going. You can do this. It's a nice touch. I should be using a ruler, but I'm just saying that just so the reader kind of helps the reader. Okay. Ooh, we should have done this in class. Daggone it. All right, here's something else. Here's a virtual special here. You also on these, you should, for these particular graphs, you should fill in your rectangles. Now, the reason is because what we're about to do later, but this is a nice preview of sheet 2.3, the back, but you fill these in, and these are like stalactites and stalagmites. If you know your earth science, when you go into a cave, you have stalactites and they grow from the ceiling down, and you have stalagmites, and they're the formations that grow from the floor up in caves. So the red there would be like a stalagmite, and the blue areas here are like stalactites. And these areas have a lot of meaning, okay? We're not just doing this just so I can color, although that's good. These grow, the negatives grow from the axis down, from the origin axis, the dividing line from what divides the first and fourth quadrant. They grow down, negative velocities, and the positive velocities grow up. So that's something that only the virtual kids get, or whoever's watching this. Okay, there are some Easter eggs every once in a while. The last thing we're going to do on this, and then I'll leave you alone. I know this thing's going long. But the last thing I want to do on this is I want to talk about the average velocity. Well, the average velocity is first of all, I had the kids do in class, and that's what this is all about over here. I had the kids just add these 5 numbers up and divide by 5. And then I said, okay, no, that's the average, right? And they all agreed. But then the answer is wrong because that's the mean. But the mean is not, mean, MEAN. That is a simple average from arithmetic. You learned that probably in 4th grade or something. But that doesn't work here because this is what's called a weighted average, meaning that I spent more time as an old man and as the funky chicken than I did running. So it's not fair to the old man or the funky chicken to weight all of these velocities the same as if they all spent the same amount of time. It's like if you're in a teacher's class and the teacher gives you a 90 on the first paper, first assignment, you get a 60 on the next assignment, you get a 10 on the next assignment. And so then you realize you better get after it. So the test comes along, big, huge test. And on the test, you get an 80. Now, it wouldn't be fair if that teacher added these up and divided by 4, because she's given tests the equal weight of a stupid little assignment. So what teachers do is, some teachers, now I do my class by total grades, but like if you're teaching 4th graders, they don't get the idea. They can't do all that division very well. So you got to make everything out of 100. So it's obvious that they got an A, B, C on that paper. So anyway, so like teachers will, some teachers, even in high school, will weight this thing and they'll say, well, this is really 4 times 80. So tests are worth 4 times. So it's sort of like we're doing back here. And by the way, there's a question on the ACT, usually is something involving weighted averages. But the question back here is, how do I do that? I mean, that looks like a nightmare. If I got to go back and weight each one of these velocities, that's a nightmare. Because I got to look at the total time, which is 36 seconds, and then take how long the old man did, which was 9. Take 9 divided by 36, do some kind of fractional. What a mess. Here's the fast way to do it. All you do is you go to the graph, you take the first point, and now we're talking about the green triangle. You take the first point, you take the last point, because we're looking at the overall average. We're looking at a overall velocity, a V bar. And so you connect those two up. And when you do that, you find the slope of that. And I go ahead and I made a negative right triangle out of it. You find the slope of that and you get negative 0.11 meters per second. And by the way, this is called V bar. And if you have A bar, you have V bar. I mean, bars, you put a bar above something, you're telling the reader that, wait a minute, this is an average, okay? It's not an instantaneous velocity. It's not an interval velocity. It's an overall average velocity. So it's a little embarrassing to the velocity symbol because it's got to have a bar above it. But, you don't want someone thinking that's the instantaneous velocity. So someone asked, and I think in 3rd hour, and I gave them a couple discussion points. I said, could you give me some kind of formula on that? I mean, I see that you're saying it's slope, but so that was really good because then we talked about that the next day. V bar then is equal to delta X total, the TOT total. So delta X total over tau, which is, as we talked about earlier, is total time. So the V bar then would be, in this case, rise over run. That's the rise, which in this case is falling, and that's the run. So it ends up being negative 4 over 36, which gives us 1/9, which is about 0.11, negative 0.11. Okay. So I have to this is something we didn't do in class yet, but I'm supposed to represent that on this graph. And so now you have to use a different color because if you're going to overlap graphs, you have to use different colors. So I'm going to go green because we did green in the front. And I want to do that negative 0.11, which is pretty much right below the x-axis, or not the x-axis, the time axis, the horizontal axis. And then all you do is you draw that green line all the way across. And that represents your average velocity. That's something we didn't get to in class. We'll get to that Monday. Okay. So I think that finishes this sheet. I know I took a long time, but now you should be able to answer all these questions. Oh, this type of graph, it's a step function, or it's called a piecewise function, and it does represent a function. It passes all the tests. 8 says, what's the slope of the velocities? We see there's 0 up here. 9 says, did the velocity change within the interval? The answer is no. Did the velocity change overall? Yeah, of course it did, but it stepped. You see why these are called steps? They're flat. And then 10 says, draw an approximate line on the above graph in a different color, which represents the overall average. And we did that just now. So we are, yay, we're officially done. And now you are actually a tiny bit ahead of the in-class kids. Sorry, it took me, let me stop sharing here. Okay, I'm out of coffee, but sorry it took me an hour to go through all that. We had some things we had to talk about. So normally these things would be 30 minutes, all right? Okay, I'll see you guys. Go on Facebook, go to Unit 5 and ask your virtual questions. If any in-class gets on Unit 5, we won't kick them out. It's only for virtual kids, all right? We have our own problems, right? We got to deal with. So go there for questions. Go to the regular Facebook, go to Unit 1, 2, 3 for asking just physics questions, but logistics of virtual, like this test coming up. That's a good place to go. And I'll see you all on Zoom. There's a new calendar on there's a revised calendar on the Canvas, the front page. That's where the calendar will always be. Okay, and I'll see you guys Monday from 9 to 10 for a late night physics session and last session before the test. See you.